Hello, welcome to this Unreal Engine tutorial. I'm the Festmaster, and today I will be finishing making some basic platformer mechanics from the third person template. And today, we did double jumping last time. Today we'll be doing wall jumping, wall running, and sort of dash mechanic that can be both done on the ground and in the air. Alright, so let's get started. To begin with, we're going to do the dash mechanic. So in the project settings, under input, if we drop down action mappings, we need to have a new action mapping to control when we dash. So click the plus, we'll call this dash, and just change this to the E key, right here. And then, in our third person character blueprint, we can begin to write the dash code. Now, I'm going to move it quite a bit out of the way because the jump code is going to get messy after this. So if we search for dash, we now have an event for dash. Now there's a couple things that we're going to want to do. First, we'll create a branch, and then off the condition we can do an AND, because we have two booleans that we want to put in here. So we can create two variables. The first one is can move and turn. And the other is can dash. So we want to plug both of these into here, and then after compiling, we can go set the default value for both of these variables to be true. And now, on this movement input, I'm just going to drag the comment out a bit so we have some extra space. I'm going to put a branch on here for each of them, and grab can move and turn, and connect that to each branch, and then just hook these branches in between the events and the movement input nodes. So this boolean will control whether or not we can actually walk around. The next thing we want to do is create another branch and get our character movement component and get is falling and plug that into the branch. And then we will want to set dash to untrue and set can move and turn also to untrue, like this, so that dash is only set to untrue if we are falling. The next thing we want to do is create a new macro. We'll call this dash direction. Now this is going to be an interesting macro. So on our input side, we will want to add a new execution pin, as well as a new execution pin on the outside. And the way that I'm getting these blank labels is just by hitting space. The next thing we want to do is grab our character movement component and set gravity scale to 0. Then we want to get a launch character, and drag this pin onto the input. So we have a launch velocity node. Then we'll hold D, click for a delay, and drag that duration pin onto this for a duration node. And then, well, on this launch character, I forgot, check X, Y override. Then we can copy this launch character over here And then, if we get the character movement component, and get max, where is it? Get max walk speed, and get actor forward vector, multiply this by a float, and then we get the move forward. So this is the same value as this axis value on the move forward event. And just grab another one of these, multiply vector by floats, and this is our launch velocity. So that will allow us to move forward however much we are currently moving, and we take the Z override and drag it also onto the inputs. And then we can just copy this character, well, I'm going to move this down for ease. Character movement and gravity scale. Paste it here. And set it back to our default of 4. And plug that into the output. Now back in our event graph, where we were writing our dash, we're going to use this macro, and creating a new variable, we'll call this dash velocity. Change this to a float, and compile so that we can set its default value to 5,000. Now we want to get actor forward vector, multiply this by that dash velocity, and plug that into the launch velocity. The duration we can set to be 0.1 and just leave the Z override blank. We'll be using the same dash direction later for the wall running with different settings, which is why we made it a macro, because it's easier to reuse the code. And then off of here we can set can move and turn to true and reset the double jump. So this will allow us to double jump both before and after we dash. So now going in here and playing, if E, we see we dash, double jump, dash, and I have forgotten something. Here, before we go into this do once, we want to set can dash to be true. That way we can double jump, dash, double jump again, dash, double jump again. And you'll notice that we can dash as many times as we want along the ground, but in the air we can only dash once, which is the whole purpose of the can dash variable. So that's our double jump. Now we can build the wall jumping and the what is it called? Wall running. Now some people have used another collision component, another sphere collision component to detect when they're against the wall, but this is not ideal because you don't get the wall's normal when doing this. So what we're going to do is do a sphere, if I can spell it, sphere trace for objects, add a branch, and just grab our character movement, is falling to be be true because we only really want to trace for wall running and wall jumping when we are currently in the air. Get the actor location, plug this into both the start and the end because we only want to do a single sphere. Well, for radius, we can get this capsule component, get scaled capsule radius, add about 4 to it, and that is our radius for this. So that'll be 4 units wider than this capsule on each side, it's right at the center of the player. For the object types, we can make an array, and we will want to do both world static and world dynamic. And for actors to ignore, we can make an array and just add the self into it. Now, off of this, you'll want to put a branch and plug that into the return value, and then take out the hit and break the hit result. And here we're going to create 3 variables. The first is called isTouchingWall, and it is a Boolean. The second is called wallNormal. It is a vector. And the third is called isWallRunning. And it is also a Boolean, and we will use that later. But it's used here, so we're making it now. Now, off of the true, we want to set isTouchingWall to true, set the wallNormal to the normal of the hit result, and then and copy these. Off of the false, we want to set isTouchingWall to be false. The normal we want to set to 0, and we want to set isWallRunning also to false. What this will do is when we have built the wall running mechanics, as soon as you are no longer touching a wall, it'll automatically stop you from wall running. So if we select all of this, comment it, we can label it wall detection. This we can also comment out and label turning. Because now we need to take everything in the tick event and move it off to one side, and everything in the jump event and move it down, because it's about to get way more complex. Actually, let's not move it down, let's move it all the way out here and move this dash here, comment that out, call it dash. So this is all of our double jump code here. And if we comment the jump and stop jumping out, we can call this defaults. And we're just adding these comments in here so that it is much easier to organize our code and less easily confused. And we can comment this and call it double jump. Now there is something that I didn't do last video that I want to add this video because it makes it a little bit easier. If we get the character movement and get jump z velocity and split the struct pin on the launch velocity, we can just plug that straight into z, and it'll automatically figure out what our jump velocity is, from our character movement. So when we edit the character movement, we don't have to go and reciprocally edit everywhere that we have a jump like that. So the first part we're going to make is the slightly easier wall jump. Right? Let me see if... So the first thing we need to do here is throw in a branch, and get is touching wall. If this is false, we can go into the double jump. If it's true, we'll just create another branch that we will use later. And this we can just leave to true because we will be creating a Boolean statement for this later when we build the wall running, but not at the moment. Now, for the wall jump, we'll need a do once and a custom event. Called reset wall jump, which is plugged into the reset. And we can plug the true into the do once. Off of this, we'll make a sequence, and then a launch character, which will be plugged into 0 on the sequence. Now we will need the wall normal and another variable. Call this wall push off strength, which is a float, and after compiling we can set this to 750. We'll be using this variable as well as the character movement and the jump z velocity from that. Vector plus vector, and then we can split the struct pin on the bottom vector, plug the jump z velocity in that, and then do a vector times float, and multiply the wall push off strength by the wall normal, and plug that into the top of the vector plus vector. And then add another vector to this, and this is the get velocity. And this is what we will plug into the launch character, and we want to do both the x, y, and z overrides. And then, where's our tick? On our tick, we are going to put a sequence after the can dash, connect the first one up to this double jump, and then basically replicate it again. Reset wall jump this time, and a custom event wall jumped, which back at our wall jump we will call here. Now if we compile this and play, you'll notice we can go up to this wall and jump off of it. But that does not interfere with our double jump. We can double jump before, well, it's kind of tricky to do it before. But there it's a little bit. But we can also see it happening after. So the wall jump and the double jump are not interfering with each other at all, which is very nice. And if we comment this out, we can label it wall jump. And then I'm going to move these defaults down and the wall jump down again. Alright. Now for the wall running. And we need to determine whether or not we're actually going to be using a wall run. So the first thing we need to do is create another macro. And this is called get wall intersect angle offset. It has a long name, but it is a very descriptive name. This is exactly what it does. We're not going to be using any inputs for this. So the first node we're going to want is a make transform. And then we want to get the actor forward vector. And then there's a node we need called get azimuth and elevation. And we will be needing 2 of these. And we will also be needing the wall normal. We'll plug the wall normal and the actor forward vector into the indirections and the transform into the reference frame. And this is basically a blank reference frame. And then we will subtract one azimuth from the other, and then we need to get a delta for a rotator, and split the end struct pin and the A struct pin, and plug this into the yaw, and then the yaw directly onto the output, and we can call this return. The purpose of this delta rotator is to normalize this value, because this value could be anything. If this yaw and this yaw are both around negative 180, we'll have a very negative value here, but we want our return value to be between positive 180 and negative 180, and that's what this delta rotator does. By default, it normalizes whatever you pass through it. And so passing through a rotator with just yaw and not actually subtracting anything from it will just normalize that rotator. And then we can get that yaw right back from it. So, back in our event graph, we can get the wall intersect angle offset. And then we need to create a new variable called wall run degree acceptance. Get that, compile, and set its default value to 45. This will be the angle that you can hit a wall while in the air and then hold space to start wall running. The lower the angle, the more in line with the wall you have to be. So, the first thing we need to do is nope, that is not the correct node. Add 90 plus this value, and then 90 minus this value. It's important to have the 90s on top because we're getting this amount of difference. And then we will need a float greater than. No, not a float greater than or equal, or just a greater than. And plug that return value into, or the return into the bottom one. And then a float less than. And then a Boolean or. And plug that into our condition here that we left blank. And then if we comment this out, then wall run or jump. So now we know whether or not we're going to be wall running or wall jumping. We can start building the actual wall run code. So just like before, we'll create a doOnce and a custom event called resetWallRun. Which will be plugged into the reset of our doOnce, and then the false off of the branch connected to our determine wall run or jump will be plugged into the doOnce. Now we'll want to immediately create a sequence off of this. And then we'll need isWallRunning. We want to set that to be true, and then get canMoveAndTurn and set that to be false. And then we want to use the dash direction that we created earlier, set the duration to 0.5, and include the Z override. Then we need to get the wall interset angle offset. If 0 is less than or equal to it, you can use a select, and then a rotate vector. Split the struct pin on the rotator, plug the Z or yaw value into the return value of the float, and set the false to be -90 and the true to be 90. So what we're doing here is basically when you hit a wall, this is going to be pointing along the flat part of the wall in the direction that you're moving. That's what this vector is going to be. And we just need to take the wall normal and plug it into the rotate vector. And so that's going to be how we find the direction of the wall jump. Now we multiply this by a float, and then get the character movement, get the max walk speed, and plug that into the multiply as well, and then that gets plugged into our launch velocity. And then we can set isWallRunning to be false, and set canMoveAndTurn to be true. Comment this wall running, and then back at our tick event, create a new pin on the sequence, another doOnce, resetWallRun, and a custom event for wall ran. Plug that into the reset, plug that into doOnce. Oh, I forgot to mention that these should have their start closed set to be true. And then off of this sequence here, call wall ran. Now we can compile this, and when we play, if we start running and approach a wall, okay, that's interesting. Why is it doing that? I did set that correctly. Perhaps I've made a mistake somewhere. I forgot what it is. This needs to have an absolute value off of it. And then once you have that abs there, plug the result from the abs into your greater than or less than. Alright, after an annoyingly long time debugging this later, I realized what my problem was. I had these pins flipped. The absolute value is supposed to go into the top, and the results from the math nodes into the bottom. So if I can just clear out all this debug code. Let me approach the wall. and run along it like that. There's no special animation for running along the wall. You just glide along it until the time cancels and you fall down. And that is it for this tutorial. So just in overview, we have the double jump mechanic, the wall jump mechanic, the dash mechanic, and the wall running mechanic built into this better feeling third-person 3D platformer created from the third-person template. Thank you for watching, and I will see you next week for another tutorial.